Okay, this deals with inequalities in triangles. Basically, you can order angles based on the sides that they're opposite. Angle opposite biggest side is biggest angle. Angle opposite smallest side is smallest angle. Or you can do this the other way around. If you need to find out what the side lengths are in relation to each other, the side that's opposite the biggest angle is the biggest side. The side opposite the smallest angle is the smallest side. So it works both ways. So number one, like the side lengths, we can see that K is the largest angle because that's opposite the 5.8 side. L is the medium size angle, that's opposite the 4.3. And M then is the smallest angle opposite the 2.7. Looking at number two, we want to find the smallest angle first. So the 105 is the largest angle. We got 3x versus 3. This angle that's opposite the x is going to be smaller than the angle that's opposite the 3x. So in order, we have basically D, C, and E. In triangle 3, we have a right triangle, so that hypotenuse is the square root of 52, and angle G is the largest angle. Write the sides in order. Now they're giving us the angles, so we have to find all the angle measures and then order the sides. So we got a 45 and a 75. That adds up to 120, which leaves angle M a 60. So in order, MN is the smallest side, and the next side is going to be ON, and then we have OM. In number 5, 138 from 180 is 42. So FH is going to be the smallest side. The side opposite the 42, GF is going to be the next size side, and then GH is going to be the largest side. We have a 30, 60, 90 triangle here. T is going to be a 60. So in order, with the side opposite the 30, TU is smaller than the side opposite the 60, which is UV, which is smaller than TV, which is opposite the 90. Here we have some triangles that are combined together, so sometimes we have to do each triangle separately and then kind of see how they relate together with each other. So we can see that C needs to be at 38 degrees to get 180 out of that triangle, and D needs to be 38 to get 180 degrees out of that triangle. And so when we match, we want to find the shortest segment in the diagram. So we're looking at the smallest angles. DB is opposite the 30, and DB is also opposite the 38. So in the right-hand triangle, DB is the shortest side. In the left-hand triangle, CD is the shorter side. So CD is going to be the shortest side. CD is smaller than CB, or than DB, which is smaller than CB. And looking at triangle 2, kind of doing the same idea. The smallest angle gives us the smallest side, so DB is going to be smaller than BA, which is smaller than DA. And from those, we can see that CD is the largest side. So there's a couple of ways of seeing that CD is the largest side. The same idea for number 8. We need to find out what those missing angles are. 48 and 47 is 105, so that gives 75 degrees for that angle at Y. And then for the angle at W, WYZ, we find out that that's 45 degrees. And we want the shortest side. So in the top triangle, the shortest side is going to be XY. In the bottom right triangle, the shortest side is YW. So we're really looking at XY versus YW, but if we kind of do these in order, we can see that between the two different versions in the triangles, XY is got to be the shortest side, because XY is less than YW. Looking at number 9, which third length is longer. So this is using what we call the hinge theorem. There's actually a side angle side type pattern going on. And if you have a side angle side pattern, then the A part in the middle, the angle part, lets you predict how the sides are going to relate to each other. So if you have two congruent sides in the included angle with two other congruent sides, those included angles determine what the longer side is going to be. So with number 9, we can find out that FD is the longer side. And with number 10, when we look at those, we can say that LN is bigger than QO because the 125 is bigger than the 78. To find out whether we can make possible triangles, the third side has to be less than the sum of any combination of 2. So 6 and 3 is a 9, 6 and 2 is an 8, 3 and 6 is a 9, 2 and 3 is a 5. So all of those are within range. They're all smaller than any combination that we can get. So yes, we can make a triangle out of those dimensions. Looking at number 11, same idea. 15 and 11 is 26. All the numbers are less than 26. If we look at 12 and 11, that gives us a 23. All the numbers are less than 23, so we can also make a triangle there. Looking at number 13, we've got a 15 and a 15. That adds up to 30, so 1 is less than 30. The other combination basically is the same, so that one works. But if we look at number 14, 4 and 5 adds up to 9. That's exactly the length of the third side. You can't really make a triangle where you don't have a little bit of angle in it. Try drawing a 4 and a 5 and a 9-sided triangle and see what you get. You're just going to get two lines that kind of lay on top of each other. So 14 doesn't work. Looking at 15, another thing that we can do to find the range of values for the third side is look at the sum and the difference of the two sides that they give us. So the remaining third side has to be less than 20 because that's the two added together, and greater than 4 because that's the difference of the two.